What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to have a look at something called complementary probability. And the first thing we're going to look at is what the word complementary actually means. Obviously we know in normal language we're talking about, oh, I gave someone a compliment, I'm a nice person. But that's not what it means all the time. Complementary also means that two things or three things can go together to make a whole. So if you have a burger, right, say from Macca's, you want to make that a whole meal, you might add chips. So burgers and chips complement each other to make the whole meal. And this is just one way you could kind of think about it. So in probability, what we're talking about with complementary is we're looking for things that could happen together that actually make a whole. And the whole there is what kind of underpins this entire idea. And we're going to get into it in just a second. So for example, if we use this online spinner, we've got four options. We've got blue, red, yellow, and green. And I want to know what is the probability of getting blue. Well, because they're equal outcomes, right? They've all got the same chance. The chance of getting blue is just 1/4. And then another question that I can ask you is, okay, well, what's the probability of getting red, yellow, and green? And that's pretty obviously 3/4. So what's important to know here is that there are no other options, okay? I have to get one of these colors when I do the spin. So another way that I could say red, yellow, and green is that I could say, hey, what's the probability of not getting blue? And this would also be 3/4. And so because I absolutely had to get one of these colors, there was no other options, I can say that the probability of getting blue plus the probability of not getting blue is equal to 1. It is certain. And if we're going to do this mathematically, we could say that a quarter, which is the probability of blue, plus 3/4, or the probability of not getting blue, is equal to 1. That would be 4/4. So mathematically, this works as well. And so because this happens, this is where intuition and maths kind of combine really nicely. We call these two events, blue and not blue, complementary. And what's really important is that it equals 1. It certainly happens. One of these two events definitely is going to occur. And that's really all we need to know. So for example, if I said, what's the probability of rolling a 4 on a die? You would say, oh, pretty easy. That's 1/6. Happy days. But then if I asked you what's the probability of not getting 4, and that's what that little line on top of the 4 represents, that's really easy as well. There are 5 outcomes that are not 4 out of 6 possible ones. So we would just say that's 5/6. So the actual formula we've got is that the probability of A plus the probability of not A, or A with that little dash on top, is equal to 1. And that is the definition of a complementary event. One of them has to occur. Something that we've got to be really careful of is that not all events are complementary. We have to make sure we're accounting for everything when we do these questions. So one question you could get is, oh, how many kids walk or drive to school? So you could say that the probability of walking to school is 1/4 and the probability of driving is 2/4, right? If you looked at a survey from your 4 mates. But this isn't equal to 1. A quarter plus a half is only equal to 3/4. Because there are other options to get to school. You could ride your bike, you could catch public transport. We don't have 100% of the people that fit into these two categories. So we couldn't say that walking and driving are complementary because there are other options that people could choose. So the important thing mathematically is that we must have a certain at the end of these two complementary events, right? We have to have a 1 on that other side of the equation. Otherwise, the whole thing is going to break down. So the reason that these complementary events are so helpful is that they're incredibly easy to rearrange mathematically. Because we've got the event plus the complementary event equals 1, we can just move these things around really easily. In this example, I've got 4 out of 10 students love playing golf. How many of them don't love playing golf? You can probably work out the answer almost straight away, but it is something just seeing the equation being written, it's still a good skill to have. So because I've got the probability of golf, 4/10, plus the probability of not golf equals 1, to get that unknown, or the probability of not golf, all I've got to do is minus that 4/10 to the other side. And now here I've got my complementary event is equal to 1 minus 4/10, which is equal to 6/10. And that's exactly what we thought. So 60% of the students don't like playing golf. 40% plus 60% is 100%, so we know we got it right. So this is just one kind of look at why this is really helpful. If you've got multiple things going on, sometimes it's way easier to count the chance of something not happening and then minusing it from 100% instead of counting up everything that is occurring in that event. So it's just a little shortcut for you moving forward. Thanks so much for watching, guys, and I'll see you later.